Hello viewers, in today's session we are going to discuss one important problem from differentiability of functions, right? So in this class we are going to discuss the differentiability of a mod function in the form of this problem. And here in this question we are given that we have to check the differentiability of the function f of x, which is given as the absolute value of x minus 6, that is mod of x minus 6 at x is equal to 6, right? So we have to check whether this function f of x is differentiable at this point x is equal to 6 or not. So to check the differentiability of a function at a given point, what we do, we find out the right hand derivative and the left hand derivative, right? So if the right hand derivative is equal to left hand derivative, then we can claim that the function is differentiable at that particular point, right? So for the differentiability of a function, we calculate the right hand derivative and the left hand derivative at the given point, and if both the derivatives are finite and equal to each other, then we can say that the function is differentiable at that point. It means f prime of a, it exists, right? And if the right hand derivative and the left hand derivative are not equal to each other, or in some cases the right hand derivative or the left hand derivative may not be finite, then we can say that the function is not differentiable, right? So we have already discussed the concept of differentiability of a function at a given point in our earlier videos, right? So let us solve this problem. So let us first find out the right hand derivative. So the right hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? Where h is a positive quantity and it is infinitesimally very small, and this quantity a is the given point. In this case this point is 6, right? So in our case a is given as 6. So this is the definition of right hand derivative, and it is equivalent to limit, that is h tends to 0 f of a plus h minus f of a divided by h. So now taking a is equal to 6 here, we have limit h tends to 0 f of 6 plus h minus f of 6 divided by h, right? So we can also use the notation for the right hand derivative, and it may be f prime, and here we can write a positive sign, and here we have the point a, right, which is equal to 6. So now we have limit h tends to 0. Now f of 6 plus h can be obtained by replacing this x by 6 plus h. So we have 6 plus h minus 6, and f of 6 is mod of 6 minus 6, and here we have h. Now let us simplify this expression. Here 6 and 6 get cancelled, and we are left with mod of h, and here this quantity is 0, so we have simply a mod of h over h, right? Because 6 minus 6 is 0 and mod of 0 is equal to 0, right? And mod of h is simply h, because h is a positive quantity. So now we have limit h tends to 0, h over h, and h get cancelled, and we have simply 1, right? So the right hand derivative of this function is finite, and this is equal to 1. Now let us find out the left hand derivative. So the definition of left hand derivative is limit, and here we have h tends to 0 f of a minus h minus f of a divided by minus h, right? So now we can use the notation for the left hand derivative as f prime, and here we have a negative sign, and here we have a, where a is 6. So we have limit h tends to 0. We have f of 6 minus h minus f of 6 divided by minus h. And we have limit h tends to 0. F of 6 minus h can be obtained by replacing x by 6 minus h. So we have mod of 6 minus h minus 6. And here f of 6 is mod of 6 minus 6, and here we have minus h. So now we can simplify this expression. So here 6 and 6 get cancelled. We have simply mod of minus h over minus h, and this is 0, right? And since h is a positive quantity, so mod of minus h is simply h. So we can now have limit h tends to 0, and here we have h over minus h. So h and h get cancelled, so we are left with minus 1. So the left hand derivative of this function f of x at x is equal to 6 is given by minus 1. So viewers, from this calculation and discussion, we see that the right hand derivative is given by plus 1, and the left hand derivative is given by minus 1. And here we can easily see that the left hand derivative and right hand derivative both are finite and they exist. But these two derivatives are not equal to each other, because this is the condition that is in the left hand derivative and the right hand derivative should be equal to each other for the differentiability of a function at some given point. But in this case, the left hand derivative is not equal to the right hand derivative, so it implies that there is we do not have a unique tangent at this curve at this point x is equal to 6, right? So whenever we say that a function is not differentiable at a given point, it implies that we do not have a unique tangent, right? So a function is said to be differentiable if it has a unique tangent at the given point, right? So the left hand derivative and the right hand derivative should give the same quantity. So in this case, this is minus 1 and 1. So these two are different. It implies that we do not have a unique tangent. So this function is not differentiable at this point x is equal to 6. So viewers, here we can make a general statement, that is, if we have a function f of x that is mod of x minus some point say a, then this function is not differentiable at this point, that is x is equal to a, right? And if we have a function of this form, that is mod of x plus a, then this function is not differentiable at x is equal to minus a, right? So we can claim that a function say f of x, which is given as x minus 1, then this function is not differentiable at this point, that is x is equal to 1. Similarly, if we have a function say f of x that is mod of say x plus 2, then this function is not differentiable at this point, that is x is equal to minus 2, right? Similarly, we can take another example. If we have a function f of x that is mod of x minus half, then this function is not differentiable at x is equal to half. Now similarly, if we have a function say f of x is equal to mod of say 2x minus 5, then this function is not differentiable at x is equal to 5 by 2, right? So this point x is equal to 5 by 2 can be obtained by equating 2x minus 5 equal to 0, right? So we have 2x is equal to 5, so x is equal to 5 by 2. So this is how we can solve or we can check the differentiability of mod functions. Hello viewers, in today's session we are going to discuss a very important and conceptual problem from differentiability of functions, right? So viewers, we have already discussed a lot of problems in our earlier videos regarding the differentiability of functions, and we have seen that how to find the right hand derivative and the left hand derivative of functions at a given point, right? So here in this class we are going to solve this problem where we are given a function f of x that is equal to x raised to 4 over 3, and we have to show that this function is differentiable at x is equal to 0, right? So by differentiability of a function, we mean that the slope of the tangent to the curve at the given point it exists, right? And moreover, the tangent should be unique, right? So here we have to show that the derivative of this function at x is equal to 0, it exists, right? Because we are to show that this function is differentiable at x is equal to 0, right? So in order to show that this function is differentiable at x is equal to 0, we have to find the right hand derivative and the left hand derivative of this function at x is equal to 0, and we have to show that the right hand derivative and the left hand derivative both exist, they are finite, and they are equal to each other, right? So let us separately find out the right hand derivative and left hand derivative of this function at x is equal to 0. So the right hand derivative is defined by this limit, that is the limit h tends to 0 f of a plus h minus f of a divided by h, right? Where h is a very small quantity, that is infinitesimally very small, and this point a is the point where we have to find out the right hand derivative. So here we have x is equal to 0, so we have a is equal to 0. So now we have limit h tends to 0, and here we have f of 0 plus h taking a is equal to 0, and here we have f of 0 and divided by h. So we can now write limit h tends to 0, and we have f of h minus f of 0, right? So f of 0 can be obtained by taking x is equal to 0 in the given function. We have f of 0 is 0 raised to 4 by 3, that is simply 0, right? So here we have 0 and here we have h. So now we have limit h tends to 0, and f of h is obtained by replacing x by h. So we have h raised to 4 over 3, and here we have h. And now by making use of the laws of exponents, so here we have h raised to 1. So taking h raised to 1 to the numerator, we have 4 over 3 minus 1. So this is the limit h tends to 0, h raised to 4 minus 3 over 3. So we have limit h tends to 0, and this is h raised to 1 over 3. And now taking the limit, that is h tends to 0, here taking h is equal to 0, we have 0 raised to 1 over 3, that is equal to 0. right? So the right hand derivative of this function at x is equal to 0 is 0. So we can also write it like this. We have r for the right hand derivative, then f prime of 0 is equal to 0, right? Now let us find out the left hand derivative. So the definition of left hand derivative goes like this. This is limit h tends to 0, f of a minus h minus f of a divided by negative of h, right? Now taking a is equal to 0, we can write limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h, and we have limit h tends to 0, and this is simply f of minus h because 0 minus h is minus h, and f of 0 is equal to 0. So here we have 0, here we have minus h. Now we have limit h tends to 0. F of minus h can be obtained by replacing x by minus h. So we have minus h raised to 4 over 3, and in the denominator we have minus h raised to 1, right? So again, applying the laws of exponents, we can take minus h raised to 1 to the numerator. So we have minus h, and we have 4 over 3 minus 1, right? So this is limit h tends to 0 minus h raised to 4 minus 3. This is 3 times 1 is 3 over 3. So this is limit h tends to 0 minus h raised to 1 over 3, right? So now taking h is equal to 0 here, this expression goes to 0. So here we have 0, right? So the left hand derivative of this function at x is equal to 0 is it is denoted by L, f prime of 0, that is also equal to 0, right? So we can see that both the derivatives, that is the right hand derivative and the left hand derivative, exist. They are finite and both are equal to each other, right? So the right hand derivative is equal to left hand derivative and it is equal to 0, right? So we can safely say that f prime of 0, that is the derivative of this function at x is equal to 0, is equal to 0, right? And this function is said to be differentiable.